The path to unlocking the secrets of the universe usually starts with a question. And that can be kind of like brainstorming your college major. Everything sounds vaguely interesting, but we have to narrow it down. Let's put it this way. We're surrounded by information, but for data to actually be useful to us, we need to know what questions we have and what methods will help us answer those questions. Hi, I'm Sabrina Cruz, and this is Study Hall, Real-World Statistics. Asking a research question is like most fact-finding journeys. It's an answer in progress. We start from square one, explore different approaches, and finally decide what information we need to know. For example, let's say we're trying to figure out if going to a US college is even worth it. Now that seems like a straightforward question, but allow me to make it a lot more complicated. In the US, college can be super expensive, which is probably why you're watching this video. But worth can mean a lot of other things. So we could talk to students at different colleges about their experiences through things like interviews or focus groups. What we're collecting becomes qualitative data, or information that's labeled or categorized rather than concretely measured. Think about words or emotions, or a one-star review of that super spicy ramen that just reads, "Please send help." Measuring happiness or satisfaction isn't as simple as adding or subtracting numbers. If you want to work in the humanities, qualitative data will likely be part of your job, whether you're interviewing people about their experiences or finding patterns in written work. But for the sake of my sanity, let's stick to money. Let's briefly throw our values out the window and decide that worth equals money. We want to figure out how much money you might make after getting a bachelor's degree. To answer that, we would need to collect information from colleges nationwide about recent graduate salaries. That's quantitative data, which are anything that we can measure or count. So we'll try to figure out, does going to a more expensive college lead to a higher salary? Great, that's settled. But now we have to get that data. If you're chronically online like me, you might already have a strategy. Google it. By searching through online records, we could find information on different college tuition rates and post-grad salaries. Or we could send out surveys asking graduates to tell us how much they paid to go to college and how much they make now. Then we could run tests to see if higher tuition rates lined up with higher post-grad salaries. That strategy is what we call correlational research. That means we're identifying and measuring the association between our two variables. And we could do that in a couple of different ways. Like, if we wanted to know if a more expensive college is worth it right away, we might look at current salaries for a bunch of people who graduated just last year. Using that data, we can do a cross-sectional study, a study based on a group of individuals that's measured one time simultaneously. Or if we wanted to know how salaries shake out across whole careers, we could ask people about their salaries over and over again, say once a year from their graduation to their retirement, collecting data multiple times over the course of our study. That's called a longitudinal study, and if you got 40 years to spare before you make your college choice, go for it. Either of those methods lets us see how tuition and salary relate to each other. Maybe as tuition goes up, salary seems to follow. Correlational research like cross-sectional and longitudinal studies help us learn about how our variables vary and let us make predictions based on those observations. So in a world where only tuition matters based on the affordable amount I spent going to school in Canada, I predict I will never be a millionaire. Womp womp. But hold up, correlational studies have some limitations, namely that there are lots of other variables in people's lives. Like maybe you spent a lot of money on college, so you became a corporate lawyer to pay off your debt. Or maybe you went to community college, saved money, and were able to become an artist. Or maybe being born into a wealthy family gives you more access to both expensive colleges and high-paying careers. You know, the American dream. Anyway, because correlational studies can't control those other variables, they can't establish causation. So even if we do find an association between our variables, that doesn't mean that paying higher tuition leads to a higher salary later on. To see if that's true, we need another kind of study. An experiment. Things are about to get wild. The point of an experiment is to control those other variables, like your area's unemployment rate, your socioeconomic status, your corporate law aspirations, or lack thereof, so we can see if higher tuition really causes higher salaries. And let me tell you, that's gonna be a lot harder than Googling. Like, to answer our question, we'll need to start with a group of people whose lives are exactly the same. We'll have to raise them all together from birth in a laboratory of our creation. We'll give them all the same primary and secondary education and show them the same reruns of exclusively my videos growing up. And how cheap or expensive things are won't matter because everything we give them is free. Once our lab-grown children come of age, we'll have a perfect group of variable-controlled adults to participate in our experiment. Then we'll scramble up our participants, assign them to a cheaper or more expensive college financed by a mysterious benefactor, and then set them free for the first time in their lives to complete their college education. Now, as long as our participants don't flee the country at the first hint of freedom, we've got a real experiment on our hands. After they graduate and find jobs, we'll find out how much money they make. Because the only difference between our participants' lives was the college they went to. If we still find that higher tuition matches with higher salaries, we can say that going to a more expensive school probably causes you to earn a higher salary. But let's be real, much to the chagrin of psychologists and sociologists everywhere, we probably can't get our hands on 100 unblemished newborns to conduct our perfectly controlled experiment. Even if we can't control all the variables, though, we can control at least some of them and do what's called a quasi-experiment. Like, maybe instead of raising babies in a lab, we'll just make sure that each of our participants has the same chance of attending a cheaper or more expensive college as everybody else in the group. We'll randomly assign them to different colleges, and our wealthy benefactor will foot the bill. Random assignment helps us make sure that some underlying factor, like socioeconomic status, doesn't determine what college our participants go to. We'll get a wide variety of participants at all of our different colleges, so even though we can't get rid of individual differences, we can at least minimize their impact a bit. Or we could try a repeated measures design instead. We'd have to do some work beforehand categorizing colleges as cheap or expensive. With that done, we'd look for adults who haven't been to college yet and ask them about their current salaries. Then we'd send them to college, with half of them going to schools that we've decided are relatively cheap and half going to the expensive ones. They'd graduate and we'd ask them about their salaries again. Then we'd send them back to college, this time to the schools they didn't attend. So if you went to a cheap school before, you'd have to go to an expensive school after, and vice versa. After graduation, we'd ask again about salaries. This works better for things like clinical trials, but go with me here. In each case, we'd measure each person's college tuition against their increase in salary after college. And we'd assume that because college is the biggest thing that changed in between measures, it's at least partially responsible for that increase in income. By measuring these same participants across different conditions, we'd help control for individual differences and make sure we're really measuring the effect of expensive colleges instead of trust funds. But before we can correlate or experiment or quasi-experiment with people, we have to decide what people we're talking about in the first place. A research question is usually focused on a population of interest. For our example, we want to know if higher tuition leads to higher salaries for all 200 million-ish adults receiving bachelor's degrees in the US every year. But you can forget about 200 million babies in our lab, and even sending out a survey to that many people is going to be very hard. So we need a way to streamline the process. Sampling involves choosing a portion of people or things, a sample, if you will, from the population we want to study. Instead of studying the whole population of 200 million adults, maybe we'll use a sample of 200. But since we want to draw conclusions about the whole population, we have to make sure our sample looks like it. A good starting point here is to take a simple random sample, where everyone in the population has the same chance of being selected for our study. That's the ideal approach. If we don't randomize, we run the risk of getting a sample that's biased and doesn't represent the whole population. Like, what if instead of random sampling, we only collected data from people who are within the survey throwing distance from us? That's everywhere in the lovely state of Indiana, folks. That technique is called convenience sampling. That data we collect are chosen solely based on how easy it is to get it. But as great as Indianapolis is, that sample wouldn't necessarily represent all the college graduates from Wyoming or Texas or Arizona. So even though we might learn some cool stuff about Hoosiers, we couldn't draw accurate conclusions about our whole population. But that doesn't mean we can't use some kind of technique to pick out our sample. In fact, sometimes different sampling techniques work even better than simple random sampling. For example, we want to make sure our study accounts for graduates of historically women's and historically black colleges. But we know that those schools only make up a small portion of the total number of colleges in the US. If we just sampled randomly, graduates from these types of schools might not appear in our sample at all because they're outnumbered. But a stratified random sample can make sure we capture them too. With this technique, we group our population of all college graduates by a certain characteristic, in this case the type of college. Then we take a random sample from each group to make up our final sample. This technique ensures that each group gets to contribute to the overall sample. And the logistics of sampling can also help us consider other approaches. A random sample of 250 people might require us to travel to all 50 states to survey them, which takes up a lot of time and a lot of money. So instead, we could use cluster sampling, where we cluster participants by some logistical detail and get data from the entire cluster. With that technique, we could break the US into smaller geographical units, like regions or counties, and pick a few of those at random. That way, we get all different kinds of participants from all over the country. No matter how we sample, it's good to think about randomization. That means assigning participants by chance to different groups. That way, some will receive the variable being tested and some won't, which will help us account for any outside variables that could impact things. Let's pause though. The realities of sampling are that someone else using the same procedure may come up with a different sample as they try to answer the same question we are. That means they may also reach a different conclusion. Sampling errors are discrepancies that arise because we are looking at a sample rather than the whole population. Like if our sample happened to be heavy on the Ivy League, we'd likely find that our sample tuition and salaries are both higher than the national average. But the good news is that some discrepancies are expected. We can plan for those errors and gauge how valid our conclusions really are. So even if we find that we're not 100% sure, we could be 90% sure. And when we make decisions, knowing about that uncertainty is just as important as the decision itself. We know that collecting data is a process filled with many decisions, and testing the untestable is hard. We're coming up with conclusions about things we can't always exactly measure. Like, data may convince you that an expensive college is worth it, or inflation might make sky-high tuition seem really unappealing. But it's good to know the ways we can and can't answer a question. Besides, you'll be glad that you thought things through before making a decision. In a lot of cases, that means you're saving yourself time and money. If you're enjoying this series and are interested in taking the full study hall real-world statistics course and earning college credit from ASU, check out gostudyhall.com or click on the button to learn more. And if you want to help us out, give this video a like, comment your college tuition, and smash that subscribe button. Thanks for watching. See you next time.